pressure. In yesterday's class we have started about the osmotic pressure. It is the last colligative property in our syllabus. Okay, once again tell me, what do you mean by this osmosis means? In case of osmosis means nothing but the flowing of solvent from pure solvent to solution. The flowing of solvent molecules from pure solvent to solution or from low concentrated solution to high concentrated solution. Low concentrated solution to high concentrated solution through semi-permeable membrane. Is called as what means osmosis we are calling. What do you mean by osmosis means? In osmosis experiment, always the solvent molecule will flow from pure solvent to solution, otherwise it will flow from low concentrated solution to high concentrated solution through a semi-permeable membrane. It is called as what means osmosis we are calling. It is to be called as what means osmosis. In experiment of osmosis, very important role is played by the semi-permeable membrane. Why the membrane is called a semi-permeable membrane means it is allowing only the solvent molecules to pass through it, but it is not allowing the solute particles to pass through it. That's why the membrane is called as what means semi-permeable membrane. The membrane is allowing only solvent molecules to pass through it, but it is not at all allowing the solute particles to pass through it. Hence that membrane is called as the semi-permeable membrane. Yesterday we discussed about the examples of natural semi-permeable membrane. Which substances are acting as natural semi-permeable membrane means pig's bladder and parchment paper. These are acting as natural semi-permeable membrane, as well as cellophane. It is one example we can say for synthetic semi-permeable membrane. Gelatinous precipitate of cupric ferrocyanide. It is an example we can say for artificial semi-permeable membrane. Gelatinous precipitate of cupric ferrocyanide. It is one example we can say for artificial semi-permeable membrane. Yesterday we discussed about those examples. Which substances are acting as what means semi-permeable membrane. Next, today we shall discuss, in yesterday's class only, we have also learned about the formula of osmotic pressure. What is the osmotic pressure formula means? So two formulas we are having for osmotic pressure. First formula we can say, so this is the solution. The hydrostatic pressure exerted on solution. The hydrostatic pressure exerted on solution to prevent the flow of solvent, through semi-permeable membrane. It is also called as nothing but what means osmotic pressure we are calling. The hydrostatic pressure exerted on solution to prevent the flow of solvent through semi-permeable membrane. It is also called as osmotic pressure. For this case, the formula of osmotic pressure what means pi is equal to HdG is the formula. Pi is equal to HdG. And one more formula we learned yesterday. What is osmotic pressure relationship? What the scientist by name Van Hoff, he observed osmotic pressure of so many dilute solutions and ideal solutions, and he proposed some relationship. Osmotic pressure is directly proportional to concentration, and osmotic pressure is directly proportional to temperature. If you combine the both, we are getting osmotic pressure pi is proportional to Cp. If you remove this proportionality constant, pi is equal to CRT, and finally we are getting one more formula, pi is equal to WRT by M into V. This is the one more formula we learned yesterday about the osmotic pressure. Pi is equal to WRT by M into V. Yesterday I said you one concept also. among all the colligative properties, especially if you want to determine the molecular mass of protein or enzyme or any biomolecule or any polymeric substance, among the four colligative properties, which colligative property we shall use especially means osmotic pressure we shall use especially. Why? Because means why osmotic pressure is especially used means because of some reasons are there. What are the reasons we can say means what are the advantages of osmotic pressure method? What are the advantages of osmotic pressure method when compared to remaining methods means the advantages of osmotic pressure, some okay we can say mainly some advantages are there. Molarity is used in osmotic pressure experiment. Concentration means what am I? Molarity is used instead of what means molality. It is one advantage we can say. Molarity is used instead of molality. Next, one more advantage we can say, osmotic pressure value will be larger even for dilute solution. Even for dilute solution, osmotic pressure value will be very larger. And osmotic pressure, this experiment is performed at room temperature. No need of heating to very high temperature and no need of cooling to very low temperature also. Osmotic pressure, this experiment can be performed at room temperature also. So these are the advantages of osmotic pressure method when compared to remaining colligative properties. Okay, that's why especially if you want to determine the molecular mass of proteins, enzymes, nucleic acids and polymers, which method we are preferably using means osmotic pressure method we are using preferably. Today we shall learn some more examples about this osmosis concept. Okay, we shall learn some more examples. We shall discuss about some more examples of osmosis where you are finding this principle of osmosis. Okay. So we shall practice some more examples today. So we shall take a first example I am discussing here. I take into boiled eggs. When you kept in the dilute HCl solution, the outermost layer of egg is removed. Okay, we take in such eggs. Okay, we take in the boiled egg. We remove its outermost layer carefully by keeping in the dilute HCl. Now, one such egg you kept in the fresh water. Another such egg you kept in the salt solution. What are the changes you can notice? In the size of egg after some time? Can you predict it, students? Okay, so we remove the outermost layer of egg by keeping the dilute HCl. We take in two such eggs. One egg we kept in the water, another egg we kept in the salt solution. So what are the changes you can notice in the size of egg after some time means you have to follow the rule of osmosis here. What is the rule of osmosis? The solvent will move from where to where? Solvent to solution. Otherwise it will move from low concentrated solution to high concentrated solution through semi-permeable membrane. In first case, we are keeping the egg in pure water. When you kept the egg in the pure water, outside water is there. Water means solvent. Outside water is there. Water is solvent. Okay, the egg inside proteins are present in the liquid. So inside the egg you can consider as what means the egg inside part you can consider as a solution. The egg inside part we can consider as the solution. Egg inner part we can consider as a solution. Outside water is there. Water means solvent. So in this case, if you apply the rule of osmosis, okay, according to the rule of osmosis, the solvent should flow from where to where? Solvent to solution. The solvent should move from solvent to solution. That's why the size of egg which is kept in the fresh water, its size what happens means increases. Its size will be increasing. That's what we are calling as egg will be swelling. The egg what we kept in the fresh water, it is what happens is swelling. Now we should discuss about the egg we kept in the salt solution. Now this egg we kept in the salt solution. Salt solution. salt solution means you have to consider as the highly concentrated solution. Salt solution we have to consider as what? Highly concentrated solution. Now inside there it is what means low concentrated, and salt solution is concentrated, highly concentrated solution. Now here also you can apply the principle of osmosis. According to the principle of osmosis, the solvent should flow from where to where? Low concentrated to high concentrated. Hence all the liquid molecules which are present in the air, all the liquid molecules which are present in the air, they are coming outside. They are coming outside. So that's why the size of egg, what we have kept in the salt solution, the size of egg what we have kept in the salt solution, its size is decreasing. So that's phenomenon we have to call it as shrink we should call. But we have to call as what means the shrink we have to call. So okay, two examples were here. Egg, when you kept in the egg after removing its outermost layer completely. Okay. Egg after removing the outermost layer completely, when you kept in the fresh water, its size is what happening means increasing. That phenomenon we are calling as what means swelling. Egg is swelling when you kept in the fresh water. The same kind of egg when you kept in the salt solution is highly concentrated solution, and inside the egg we have to consider as a low concentrated solution. Because of this phenomenon, the solvent is coming out from the egg. Here the size of egg is decreasing. This is called as what means the shrinking we have to call. Okay, the size of egg is decreasing, we should call it as what means shrinking. Some more examples we shall learn to students. What are the examples we are seeing in our day-to-day life? That examples also we shall learn. In the making of pickles, in your home you are making a lot of mango pickles. When you are making the mango pickles, you can observe that mango pieces are kept in the salt water. Why the mango pieces are kept in salt water? For which purpose? Okay, we have to keep the mango pieces in the salt water means in the mango pieces, any water content is there, the pickle will be spoiled very fastly. The pickle will be spoiled very fastly. We have to remove all the water content present in the mango pieces. In order to remove all the water content present in the mango pieces we are keeping in the salt water. When you are keeping mango pieces in the salt water is highly concentrated. Mango pieces less concentrated. So according to the osmosis, the solvent should flow from low concentrated to high concentrated. Hence all the water which is present in the mango pieces, it is coming outside. The mango pieces will be completely dry. All the water content present in the mango pieces is coming outside. That we have to call it as the mango pieces are becoming shrivel. Mango pieces are becoming shrivel. Shrivel means nothing but they are losing their water molecules completely. Okay, with that dried mango pieces, we can make the pickle. Since the mango pieces are not containing any water, it can be stored for more number of days. It can be stored for more number of days. In that case also, which phenomenon is applied means osmosis phenomenon we are applying. Okay, in that case also which phenomenon is applied means osmosis phenomenon is applied. Next, liquid carrots. Next, one more example we can see. Limpid carrots become firm again when you keep in the fresh water. This is also because of what means osmosis. Okay, limpid carrot means you can buy the carrots. Okay, after 2 or 3 days, you can observe that the carrots will become totally dried. Okay, it will become okay. Initially, when you buy the carrots are very fat. Now the carrots are becoming very lean. Okay, that carrots again you keep in the fresh water. Okay, that carrots you keep in the fresh water. So what will happen again? We are keeping the carrot in the fresh water. We are keeping the carrot in the fresh water. So inside the carrot is nothing but it is a solution. Inside the carrot is nothing but it is a solution. According to the rule of osmosis, the water should flow from where to where? Solvent to solution. Hence the water is moving from the outside water is entering into the carrot again. The outside water is entering into the carrot again. The carrot will become very fat again. So this is also because of what means osmosis. In the same way, wilted flowers revive again. It is also because of what means osmosis. When you are taking the flowers, when you are plucking the flowers, after some time you cannot, the flower will become dried. That means flower will lose its shell. Okay, that flowers when you keep in the fresh water, again they will become very fresh again. That is also because of what means osmosis. The plants are able to absorb the groundwater. Plants with their roots, they are able to absorb the groundwater. It is also because of what means osmosis. It is also because of the osmosis. Because you can see, this is a plant is there. This is a plant is there. You get the roots. The roots are in the groundwater. Now the plant cell. Plant cell is considered as a solution. Plant cell is considered as a solution. Ground pure water is there. So according to osmosis, the solvent should flow from, the water should flow from solvent into solution. Hence the groundwater is entering into the plant cells. From the root plant cells, the water is transported to the different parts of the plant. The water is transported to the different parts of the plant. Here also, which principle is applying means osmosis principle is applied. Okay, which principle is applying means osmosis principle is applied. So in all these cases, we can observe the concept of what means osmosis we are observing. In all these cases, we are observing the concept of what means osmosis. So this is about the osmosis. Okay, today we should discuss one more thing, students, here. Okay, we can classify solutions into three types. Depending upon osmotic pressure, solutions are classified into how many types means three types. What are the three types of solutions we are having on the basis of osmotic pressure means isotonic solutions, hypertonic solutions and hypotonic solutions. Okay, the solutions are classified into three types basing upon osmotic pressure. What are the three types of solutions we are having means the first one is isotonic solutions. Isotonic solutions. What do you mean by this isotonic solutions means two different solutions having same osmotic pressure. Two different solutions having same osmotic pressure, they are called as what means isotonic solution. They are called as what means isotonic solution. Two different solutions having same osmotic pressure at a given temperature. At the given temperature, two different solutions are having same osmotic pressure. Such solutions we have to call them as what means isotonic solutions we are calling them. So the best example for isotonic solution, is okay 0.9 percentage W by V, 0.9 percentage W by V. NaCl solution 0.9 percentage W by V NaCl solution is isotonic with fluid present in blood cell. Fluid present in blood cell. It is the best example we can say for the isotonic solution. It is the best example we can say for the isotonic solution. 0.9 percentage W by V NaCl solution is isotonic with what means fluid present in the blood cell. Okay, this 0.9 percentage W by V NaCl solution is also called as nothing but what means saline water we can call. What we can call means saline water. If you are not feeling well, okay, the doctors will put you the saline. That saline is nothing but 0.9 percentage W by V NaCl solution. Okay, in 0.9 percentage W by V NaCl solution, if you are keeping the blood cell, there is nothing happening to the size of blood cell. Blood cell is not swelling and blood cell is not shrinking also, because this blood cell and this saline water both are having same osmotic pressure. Osmotic pressure same means concentration is also same. So that's why if you are not feeling well, the doctors they will give medicine to you, go to medicine entering into your body by mixing with saline water. Why? Because means okay, in the saline water, blood cell will not be having any kind of change in their size. Blood will be completely mixed with what means saline water, because blood and saline water both are isotonic in nature. Both are having same osmotic pressure and same concentration. So it is the best example we can say for the isotonic solution. What are isotonic solutions means? Two different solutions having same osmotic pressure at a given temperature is called as what means isotonic solution. The best example for isotonic solution is okay here. The fluid present in the blood cell is isotonic with 0.9 percentage W by V NaCl solution. This is also called as what means saline water we can call it. What we can call it means saline water. Okay, when the blood cell kept in saline water, there is nothing, no change happening to the size of the blood cell, because blood cell and saline water both are isotonic in nature. That's why doctors, they will mix the medicine with saline water and inject into your body. If you are not feeling well, doctors, they will mix the medicine in the saline water and inject into your body. So this is about what means isotonic solution. And the second one, we shall discuss about the hypertonic solution and hypotonic solution. What do you mean by this hypertonic and hypotonic solutions means? Hypertonic solution. Hypertonic solution. What do you mean by this hypertonic solution means? The solution which is having higher osmotic pressure, the solution which is having higher osmotic pressure than other solution at a given temperature, it is called as what means a hypertonic solution we should call. Which solution is having higher osmotic pressure, it should be called as which solution means hypertonic solution we have to call it. On the same way, what do you mean by this hypotonic solution means the solution which is having lesser osmotic pressure. The solution which is having lesser osmotic pressure. The solution which is having lesser osmotic pressure than other solution at given temperature, it is called as what means hypotonic solution. Okay, more osmotic pressure is there means we have to call it as hypertonic solution. Less osmotic pressure is there means we have to call it as the hypotonic solution. Here the very important is the example. Hypertonic solution. What is the example we can say for hypertonic solution? Blood cell kept in salt solution. Blood cell kept in salt solution having concentration more than 0.9% W by V. Blood cell kept in salt solution having concentration more than 0.9% W by V. When you are keeping the blood cell in such a when you are keeping the blood cell in such a solution, what will happen means when you are keeping the blood cell in such a solution means what will happen means if you are keeping the blood cell in such a solution, now the outside solution is what more than 0.9. More than 0.9 means it is the high concentrated solution. It is high concentrated solution. The blood cell is low concentrated solution. Blood cell is low concentrated and outside the cell is high concentrated solution. So according to this osmosis concept, the solvent should flow from low concentration to high concentration. The solvent should flow from low concentrated to high concentration. Hence the size of blood cell which is kept in hypertonic solution, what happens means it decreases. This we have to call it as shrink we should call. What we should call means shrink. Very important periodical question it will ask. What happens to the size of blood cell when it is kept in a hypertonic solution means when the blood cell is kept in a hypertonic solution, size will be decreasing. Its size is decreasing means this phenomenon we have to call it as what means shrink we should call. What we should call it means shrinking. The blood cell size is decreasing, it is to be called as what means shrinking we have to call. Next, hypotonic solution. Next one is what means hypotonic solution. The solution which is having less osmotic pressure than other solution at given temperature is called as what means hypotonic solution. Blood cell kept in salt solution. Blood cell kept in salt solution having concentration less than 0.9% W by V. Less than 0.9% W by V. It is to be solution means hypotonic solution. It is to be called as hypotonic solution. Now outside this salt solution is less than 0.9. Less than 0.9 means it should be treated as low concentrated and it should be treated as high concentrated. It should be treated as low concentrated and it should be treated as high concentrated. Now according to the osmosis principle, the solvent is flowing from low concentration to high concentration. Hence the size of blood cell what happens means increasing, that we are calling as swelling we are calling. What we are calling means swelling. Blood cell kept in a hypotonic solution, its size will be increasing. This phenomenon we have to call it as swelling we have to call. Whereas the blood cell kept in a hypertonic solution, its size is decreasing, we have to call it as what means shrinking we should call. So this is the theoretical concepts in osmosis. And one more last thing is the reverse osmosis that we shall discuss in the next class. Okay, so this is about the theoretical concept related to what means osmosis. Okay, thanks students.